Use the kinetic theory of gases to explain why when a gas is heated at constant volume, the pressure increases. When a gas is heated at constant volume, its temperature increases. Therefore, the speed of molecules increase and the rate of collisions per unit time increases. So the force on the wall increases, so resulting in the increase in the pressure on the wall. Explain why at constant pressure the volume increases. So when the gas is heated at constant pressure, the temperature increases, the speed of molecule increase, the rate of collisions per unit time increases. Now, in order to maintain the average force of collision on the container, that is the pressure, the rate of collision per unit time with the wall has to be reduced, thus the wall has to be further apart, resulting in increase in the volume of gas. So when the wall is larger, it takes a longer time for the molecule to travel from one wall to the other, hence the frequency will reduce. The figure above shows a type of constant volume thermometer that is used to determine the temperature of an oven. In the thermometer, a rise in temperature moves the piston to the right. So this is a piston. The operator turns the screw, okay, this is a screw, which compresses the spring, pushing the piston to the left and increasing the pressure on the gas. So the screw is unturned until the pressure P1 is restored to its original position. So the pointer 2 records the temperature on the calibrated scale. So this is the data for the thermometer. Now at 300 Kelvin, the spring has its natural length. The spring obeys Hooke's law. When the oven reaches its operating temperature, the spring has to be compressed by 5 mm to restore P1 to its original position. Calculate the force exerted by the spring on the piston. So for spring, F equal to KE, and that will give us 62.5 Newton. The pressure exerted on the gas by the spring. So pressure is force over area, so we get about 5.2 times 10 to the power 4 Pascal. The pressure of the gas. So pressure of the gas is given by the atmospheric pressure plus the spring pressure, so that gives us about 1.5 times 10 to the power 5 Pascal. The temperature of the gas. Now assuming ideal gas, PV divided by NT will be equal to R, so we get P1 V1 and divided by N1 T1 will give you P2 V2 divided by N2 T2. So since V and N are constant, we get this relationship T2 over T1 equal to P2 over P1, and therefore temperature of gas is 446 Kelvin. The length of the cylinder of trapped air is 0.3 meter. Given that the molar gas constant is 8.3 joules per mole per Kelvin, determine the number of moles of gas in the cylinder. The number of moles is given by PV divided by RT. So substituting values, we get 1.5 times 10 to the power minus 2 moles. State one desirable property for each of the parts of the thermometer labeled X and Y in the figure above. Justify your answer in each case. Part X should be a good thermal conductor so that it can respond to the rapid change in the temperature inside the oven. Part Y should be a thermal insulator so that minimal heat will be transferred to the spring, whose spring constant may vary with temperature.